So the average human has a density around 981 kilos per cubic meter. Um, and so if you want to figure out what fraction of a cubic meter you are, you can take your mass in kilos, divide it by 981. So if you want a person's head, which is about 8.27% of their mass, out of the water, how dense would the water need to be for a swimmer to have their head completely out of the water when oriented vertically in the water at rest? This is kind of the opposite of the problem a couple of times ago when we were asking about the ice cube. Now we're given the fraction that's above the water, 0.0827, right? 8.27%, per 100. 0.0827 is above the water. And so if we're looking for what's submerged, it's 1 minus that. So on this case, that's going to be, 0.9173, something like that. You can check my math later. Okay, so now we know how much is submerged. And we can take our density ratio. The submerged is the density of the person divided by the density of the fluid, right? Density of the person divided by the density of the fluid. And so we now know that we know the density of the person. We're looking for the density of the fluid, right? How dense would the water need to be? Now, this is not pure water. Salt water is a good bit more dense than fresh water, or a little more dense, 1.06, 1.08, 1.09 grams per cubic centimeter salt water. But then you get over in the Dead Sea, and the Dead Sea is much more dense. And the Great Salt Lake is in between. I think Great Salt Lake's like 1.6. So let's see where we get. So the density of the fluid, solving for the density of the fluid, that's what we're after, is going to be the density of the person divided by the fraction submerged. All right, and so 981, I need parentheses, 981 kilograms per cubic meter divided by our 0 point, remember you got to check my math on that. All right, and so this is going to be, 1.1 or so, whatever the math works out to be, or 1100 or so. And so there you go. That's how you get this problem in problem 5. And again, there are places, then you get down to the equator, in the ocean, you're probably up around 1.09. Great Salt Lake, I think 1.6. Dead Sea is even higher than that. Dead Sea is pretty dense. All right, that's it for this problem.